everybody. We are here from IBI at Maynooth University, and we are going to welcome all the participants here in the room and also the online participants. This event is part of the Research Week at Maynooth University. And here we have Professor Leonidas Adopoulos and Spiros from Thessaly University. They are our guests here, and we are going to hear from Leonidas about the project related to Smart City Hub. And we are going to start shortly, and our apologies for the delay. It has been because of technical issues, and we are going to hear from Leonidas shortly. And here we have some participants, physical participants from IBI, our PhD students, head of School of Computing, and also our guest from Greece. And
excellent. So I guess everyone can hear us. We don't need a microphone, right?
no, that's fine. Could you confirm that you could hear us? Line participants, one confirm. Oh,
Yes, I can
Yeah.
hear. It's Jean.
thanks, Jim.
Ioannis, are you there too?
Yes, good morning. Hi.
Good morning, Yannis. So indeed, some technical issues made us this 15 minutes delay. We're both sorry, me and Spiros, for this. We didn't mean to. So let's give a few, let's say, moments to share my presentation with Zore. In the meantime, I can make a brief introduction. My name is Leonidas Anthopoulos. I'm a full professor at the University of Thessaly in Greece. University of Thessaly is the third bigger university in Greece in terms of faculty members and students. We host approximately 1,000 faculty members and 35,000 students in 7 schools and 35 departments, covering almost all scientific domains you may can imagine or understand. Our university is spread in 5 cities, and I belong to the Department of Business Administration at the Business School, which is located in the city of Larissa. So the purpose that we are here to meet with the colleagues at Maynooth, and I would like to thank Zore for hosting us today, is to present the progress of a research project that we supervise and implement, and it is labeled Smart City Hub. I will show you shortly the presentation. Actually, the idea of this project started back in 2018, Zore, if you remember,
Yes.
during a workshop that we met, and we discussed about the potential, let's say, completion of the mission of a smart city. Actually, the idea was that we were observing that the smart city initiatives, regardless the fact that smart city is a broad scope that we can discuss, is that all of them were in the end focused on specific types of initiatives, like renovation of urban areas with the use of technology and innovation, which addressed several issues like climate change, energy problems, and so forth that we can experience even today. Trying to send you right now, sorry for.
No.
Okay. And other several projects that had to do with the improvement of efficiency with the use of technology, like in buildings or in public administration. But in the end, Internet of Things were used to embed technology with the physical environment. So we thought that smart city in the end does is to focus on specific things like collecting information, transmitting information. This was a very ambitious label, like, is this the end of the smart city era? Is this the end of Smart City mission? And we were trying to demonstrate how a black box could collect information from anywhere and spread it to everywhere, but in the standardized manner. What actually tries to do a smart city platform, I don't know if you have received the presentation, sorry, but in a more open way to utilize the smart city as innovation and being able to connect, being able to integrate all of the available types of existing or forthcoming smart city platforms. I used the Gmail to send you due to the size because it's almost megabytes. Otherwise, I will share it with In the meantime, this was the idea in 2018. We started developing an article for a QA journal, The Cities, where we had several debates with the reviewers and the editor, which helped us actually focus and limit this ambitious view that the smart city can come to an end in the end. Because actually what smart city is it's an instrument. It's something that helps a city become friendlier, more efficient. In such means we don't know what will be in the future. This is the label, this is the ambition. And in these terms, we are just limiting the role of our idea to develop a black box, something that can be called a hub, which offers ports where anything can be plugged in, disseminate information.
Yes, I think that this one.
Sorry for interrupting.
And which one?
Yeah, this one.
This one?
Yeah. Share, then you can, I think, show you. Try to share and see what are the options.
Okay.
Do you have a presentation here?
It is open.
Where is it? In the bottom?
No worries.
Okay.
Let's wait a few seconds.
Yeah.
Yeah.
Give me a second, please.
Sure. Sorry.
Could I share this?
So we're through.
Thank you.
Through Zoom. Join the Zoom. You send it to yourself on Teams.
Okay. This is my team.
Yeah.
And download.
Download. Bye.
Sharing the slides.
Yeah.
Yeah. Yeah.
Thank you. Okay,
Thank you, Paul. Yeah.
thank you so much.
Online participant could see the screen.
Yes, we can see it.
Excellent.
Thank you.
So, evolving this idea to a hub, it helped us define also a project proposal, which was submitted in this foundation, which offered opportunities for research development. It offers actually the limited opportunities. It's a very competitive arena, which proves that our idea was grounded on a serious problem. This is the HFRI, Hellenic Foundation for Research and Innovation. And we initiated this project labeled Smart Cities as Hubs, which focused on the development of a prototype that can deliver the primary idea that I tried to describe you earlier. So if we can go to the next slide, this actually SC Hub project is our Facebook page where you can follow. This project duration is 36 months, as you can see. Thank you, sir. The host institution is the University of Thessaly that I described to you earlier. These are the agencies that officially agreed to participate in the project, and 16 members joined this research team. The members come from our university. We have our colleague Zori from Maynooth University as a researcher, not the university, and the University of Siegen in Germany. We have a colleague there. I tried to describe you the problem in brief about the potential but broad smart city scope, which ranges in different domains. The practice shows the things that I described to you earlier. And it is used as an open innovation platform. So the smart city appears to play this hubness, the role of a hub, which is presented on the left, where you can see that the smart city platform that already exists, several types, coming from Cisco, coming from Oracle, different types, bigger, more famous or less famous, collect information from specific IoT sources and third-party applications and present the collected information on existing dashboards of this platform, or offers other vendors to develop different types of application and utilize collected information. Actually, the platforms play the role of collecting information and not broadcasting to others, which shows the potential business models that exist and offers the platform the availability to spread and earn money from other IoT sources or from other developers that want to have access to this information. The platforms, in brackets, own the information. So our idea was aggregated around 3 research questions: how the SC Open Innovation Platform is being transformed to a hub, how can this hub become an umbrella platform able to integrate other platforms and give control back to cities, and what is this kind of potential architecture of the hub? And of course, these 3 questions were justified that are important to be answered, because this is something that can be used to standardize the interoperability of several types of applications that are developed in the city. So the objective of our project is to define the conceptual model of the hub. You can see in the figure what we mean, that IoT in the city, several service providers, or remote service providers via cloud, or local stakeholders can use this hub to transmit and collect information. On the figure below, you can see that this conceptual model is based on the context layer, which contains the standards that can be used to define specific ways how this information can be collected and transmitted. The other layer is the API layer, which is the different slots that are offered to anyone who is interested to have access to this information. The technology layer, which shows us what types of facilities or other software is needed to make this happen. And the data transmission function, which pushes and pulls the information from different sources. The architecture that appears to be physical and relies on the conceptual model that I presented earlier is analyzed in 4 layers. The context layer that I explained earlier, again, the API and the technology and the data transmission function, which you can see on the right, which shows us how these 4-layer architecture can be integrated with several other types of services and applications. It can be also integrated with other databases on the top, City Cloud, as you can see probably, and all the third parties and local systems integrated via specific APIs and specific standards. On the figure below, you can see how this function, the data transmission function, works, which shows how different types of services can push and collect information. The services that you can see have already been defined in standards. So you can imagine that regardless the manner that a city evolves with the use of smart cities, in the end, it will go to something standardized like this one, offers these types of services and use engines to collect and transmit data. This is the reference architecture, which shows us one step further how this conceptual and physical architecture can come to reality, which shows us that this reference architecture consists of the IoT devices, which use the telemetry gateways to push information to the middleware, and connect with the business microservices, which are, as you can see, data consumers and producers. Okay. We are in the process of developing this architecture. Ioannis will show what we mean with that. But we have to test this architecture, explaining that this Open Innovation Hub, this Smart City Hub, can enable not only the usual types of smart services that are being delivered in a city, like smart water metering, smart energy handling, parking, other types of facilities, energy, and so forth. But even simple end users, schools with education processes, or biotechnology, which is beyond the typical types of services, can utilize this Smart City Hub. So we have planned to develop for the purposes of this project 3 types of use cases, as you can see, business, education, and biotechnology use cases. This will happen actually in the second year of our project, which means during the next year. And here you can see in brief what we mean with the definition of specific types of other types of use cases. As you can see, this one is a UML use case diagram in general that uses that provides data via the SC Hub, which means that any type of data provider can use the SC Hub via the standards and the API repository, develop specific API, registers this API, and provides data. And other data users and the smart city in general can feed data, and data users consume data. Something like that happens on the second figure, where you can see things about data provision via the SC Hub, which shows that, different types of providers can also feed the smart city hub, and service providers can use the data collected from the data providers in order to define new types of services. So you can imagine that if you push data via applications for education, someone in the end can use this data and develop a smart education, a smart learning service, a new type of service. This is the ambition, but in the end now we have a proof of concept, which is a publication that has published in June 2022 in this journal, The Cities, which shows that this idea, the conceptual architecture, the physical, the reference architecture makes sense, and we expect that these use cases can run. beyond this proof of concept, we have our project. I explained that it is going to last 36 months. You can see different types of deliverables that are on the fly. We expect to develop 3 conference publications within the next 2 years. We are also expecting to host a workshop at the end of the project. Typical research things, typical research deliverables that we believe they will make sense and will provide some useful findings via the use case deployment and testing. This is our team, some photos of our team actually. As I told you, 16 members have joined this project and work in this arena. We have Spiros together, Yannis remotely. And this was my brief presentation, which tried to explain the problem that inspired us, how we developed something around this idea, how we came to this proof of concept, what we have planned for the project. And during the next 2 presentations coming from Yannis, first, which shows us how the SC Hub is now a prototype, a demo that we have developed. It shows how it works in practice. And then Spiros, which will show you one kind of use case, the education use cases, and how we expect that it will work under the SC Hub. I would like to thank you for your attention. I will be here for your questions during this workshop. Maybe the remote attendance and the physical attendance can provide with questions at this stage or can collect the questions for the end of all the presentation. Zori, you can coordinate it.
Thank you. Maybe I have. Thank you, sorry.
You're welcome. Thank you.
We would like to thank you, Leonidas, for the presentation. And if there are any questions, please feel free to share your questions. And do we have any question for the moment? Otherwise, we could start with the other presentations.
From Ioannis, I guess, right?
Sorry?
From
Yeah.
Ioannis.
Yes, thank you very much. So happy to be in this group and working on this project.
Ioannis, can you speak louder and we
I
can also
can.
resolve it?
Yes, I have the microphone a bit far away. Is it better now?
Let me tell you, the rest of, not the Greeks attendance, that this is a national holiday in Greece. It's the Orchi anniversary. So Ioannis could be away actually, because he's in Greece. We could both be away actually.
You are away.
But not on a holiday, as you can see. Ioannis, thank you for being here with us.
My pleasure, and I will, as already explained by Leonidas, I will give you.
Ioannis, still we cannot hear you, but it's not your problem. Normally it's something from here.
No, it's.
I think it is, yeah, because already.
It's very low at the moment. So check it out.
You cannot hear me, right?
Ioannis, you feel that during my presentation about the concept and about the proof of concept, something is missing, you can, of course, comment during your presentation.
Can you hear me now or should I still wait?
No, we need some seconds.
Okay.
I can hear you, but not very loud.
I can use my headset if it helps.
Can you speak just to hear you?
Yes, testing 1, 2, 3. Can you hear me? Can you hear me?
There you go. Okay.
Is it better
One
now?
more.
Yeah.
All right.
Some more.
Different
Okay.
audio outputs as you can
I guess so.
realize.
Yes. Yeah.
So, Ioannis, you can make a brief introduction about your profile too. Make
So,
the rest of the people to understand who you are and why you're here.
So thank you very much again for inviting me in this workshop. My name is Yannis Nicolaou. I'm a PhD student in the University of Thessaly in the business administration, and working mostly. My research is mostly around smart cities, and integration of IoT technology standardization, and in general this problematic in this area. So I'm involved in this project primarily on part of the platform and how the VCC Hub may look like, and this is what I would like to show you now. So as part of the project, we are developing a prototype of a hub, of how it would look like if we had a piece of software or a black box, as Leonidas described, that could collect all the information and then later disseminate it to other stakeholders in order to produce additional value using the data. So for this purpose, we are using the infrastructure of the university. So we have deployed on one virtual machine part of the reference architecture that was described earlier. So a set of microservices, a connection to databases, and external connectors for devices to connect to. And right now we are in the process of onboarding sensors of different vendors, which will demonstrate the need for standardization that Leonidas mentioned. So if I can quickly start showing you around here, I guess you can't see my screen by now, right?
Yes. Yes, we can, Ioannis.
So for those of you who are not acquainted with this page, this is a kind of de facto standard used for REST API documentations. It's called Swagger. You can look it up later. So it's a basic page describing how REST API can be used. These are some endpoints we have defined. So right now we have a main endpoint called sensors, and from here we can see which sensors are registered on the platform and what data we can retrieve from the sensors. So all of these are, of course, not publicly accessible. You need to have to gain access to do that. So I have a token, luckily, and we can issue the commands. So the basic, the first query that we can send to the platform is what sensors are there. So I can just execute this command, and the platform replies back with 2. Right now we have 2 sensors connected to the platform. They are from 2 different vendors, and they are for 2 different purposes. The first one is a power meter sensor connected to a small workshop, a small workshop in the area of Attica. And the second one is a water meter sensor connected to a smart meter in a building in somewhere in Attica as well. So these sensors are live now, so they are transmitting data. Both of them, the first one is using power from the grid because it's measuring the power, so it doesn't have any issues getting some of that. The second one is battery operated. So this sensor here is working with a battery, but both of them are using the narrowband IoT protocol to transmit information. So all of this is hidden from the user of the platform because the user can just select the sensor they are interested in, let's say, for example, the power meter sensor, and can request what is the latest measurement that this sensor took. So if I execute this command, this is the latest measurement retrieved by the sensor. So this timestamp here should be actually some minutes ago. Let's see, units. It should be, yeah, this sensor transmits every 5 minutes or so. So this one, yes, it's 3 minutes ago. So this is the consumption this sensor is measuring as it was sent 3 minutes ago. And as you can see, it has a wealth of information. So all these are electrical data because it's an alternate current connection. So it has the current, the voltage, the cosinus of the phases, and so on. If, however, we query the second sensor, which is the water meter, find here, there it is. We can see the only difference is that you need to provide the sensor ID and the message type. So we can see here the measurement from the water meter sensor. So this has a completely different structure, obviously, because it's measuring a water meter and not power. And this data was sent 2 hours ago. So the sensor being operated by battery and not being online all the time sends data in not so frequent intervals. And here we can see, so this is the meter, the smart meter serial number. This is some parameters of the water meter, and these are the pulses. So by pulses is essentially, if you have ever seen a water meter, it's how many times the dial with the numbers has turned. And this meter measuring liters, this means that this particular meter has measured so far about 2,000 cubic meters. So these are 2 million something liters. So I'm not going into the details of its different technology used and the different data that these meters measure. What we can first of all observe is that as payloads, these are completely different. Each vendor is using their own structure, they're using their own way of organizing the data. So you have to have expert knowledge for each sensor type. And this is just 2 meters from 2 vendors. Imagine in a smart city, you could have hundreds of vendors deploying millions of meters. So it's very hard to really easily consume information that these meters produce. The second thing that I kind of didn't focus earlier is that in order to retrieve the data, I had to know the message type. So in the platform, we have modeled different message types, so we can retrieve the relevant data from its meter. This is also something that is dependent on the vendor. These are just 2 examples of areas where standardization could help. And by standardization, in this case, we don't really expect each vendor to comply with the standard and do whatever a standardization body is doing, but rather that the SC Hub acting as the standardization gateway, so getting all this information from the sensors in whatever format they send, but then presenting them to the users of the platform in a standardized and unified way. So it will be much easier for the consumers to use the data. The second point that we are now investigating with this API is how the actual API would look like, because this here is just our interpretation of how anyone could retrieve data from sensors using the REST API, but obviously this is not the only way. Another engineer, another architect may have developed this API differently, using the REST API verbs in a different way, the endpoints in a different way, and so on. And this is just one of the possible API solutions, because REST is not the only way to connect with services and platforms. You could be using GraphQL, you could be using MQTT, you could be using other APIs. So that's the second part of the research we are currently looking into, if it could be standardized or at least defined what are the options for the APIs, depending on the use case. And then within its API, or rather independent of the API itself, how the payloads can look like, so that if a third party accesses this hub, they can consume the data without having expert knowledge of whatever is going on behind the scenes, regardless of the vendor, the type, or even another platform that may be feeding data to this hub. So I hope the point got through. Do you have any questions or comments?
Yanis, for the presentation. That was really interesting. And if we have any question, just please feel free to put your question into the chat box. Sorry, unmute your microphone if possible, and just mention your question. Thank you so much. And are we going to have another?
Yes, I'm going to be next, but we have to solve the problem of sharing the presentation. And the first one is to transform from the Keynote format to the PDF. So we have 2 steps to take. Just give me a second, please.
So far, Zori and colleagues, if you have any points of discussion or questions, more exploration, especially since Ioannis will not be here with us during all the time. Maybe we will have him for 10 more minutes.
Okay, yeah.
So Yanis, you are still here with us? Okay.
You can mute, guys.
You are muted, Jens.
Sorry, yes, I'm here, just turned off the camera to not consume a lot of bandwidth. So I will be here for the next 20 minutes or so, but even if something comes up later and there's any questions, of course, we can answer
Sure.
it offline. So,
Thank you, Yanis. And we have Marcus Alferes on the call. He's director of the IVI, and we have a message from him to you. And if Marcus, you have any.
Hi, Marcus.
Word?
Thank you for your kind words.
I think, I don't know if he's off.
Okay.
You know that he's on the way.
So as you can see, we're now beyond the proof of concept.
Yeah.
We're just, we are running this prototype. We're going to make it more user-friendly
Mhm.
to develop something that makes real case. I don't know, Yanis, if you have any kind of even screenshots about how it will look like after the completion of its form, showing things that make sense to the end user. If you have-
So what I showed you is more the technical documentation slash experimentation platform for a REST API. So it's pretty standard, and anyone developing or writing code is very familiar with these things. As far as the end use case, that will depend obviously on the use case itself. So right now we are still in the process of developing them. So it would be kind of premature to have already screenshots of that. That will be an iterative process. So as we, on the one hand, onboard more sensors, on the other hand, understanding better the use case, this will converge to how the end result will look like. And in the process, we are really looking into how this can be standardized. So it's not a one-off experiment, but more something that can be reused and be replicated very easily in different cities or even in different contexts as a concept.
Thank you, Yanis. So as you can see, perhaps the SC Hub has no picture for you. It will be there and able to transmit information among different types of players. But we will try to visualize and make sense to people who are not familiar with the case. We don't know if we will transform it to a product.
If I can offer an example, so think of it as the physical hub you probably have in the meeting room that connects all the cables from all the devices there, like the telephone, the computer, the Wi-Fi, the camera, the screen, the audio. And using that, you create a virtual meeting room experience. So what the SC Hub is actually that hub, but in the virtual world, not in the physical world in terms of cables. So that's the parallel
Exactly.
I can make to make it more tangible. So yeah, if you want, we can go a step deeper and show you the code that runs behind that, but I guess that would be even less understandable. For some people it's exciting, that's why they become software engineers, but I guess it's not for everyone. But again, if there are any questions or technical questions on how the services, the deployment, the infrastructure behind the scenes, I'm happy to either discuss today or in a follow-up call. Happy to do that.
That's true. Spiros, only a few seconds and
Yes.
we will be ready. At this stage, for the participants, we have managed to come to an agreement with the water utility operator of the city of Larissa to collect some information from smart water meters and define rules for these types of data. We are in the progress of integrating SC Hub project with another project, which is, let's say, on the fly for the next 18 months, and sprawl different types of sensors in the city and calculate energy consumption. And in the meantime, we will also develop the use cases that we told you before, especially the ones that Spiros is going to present for you. We will come to real outcomes quite closely, right, Spiros? We don't expect
Exactly.
to take us really long for that.
I'm
So
gonna
yes.
use my presentation as well here, so
Whenever you're ready, sorry.
Yeah.
Has it arrived?
I just share the PDF with you.
Yeah.
I share the PDF with you because it's easier for you, I suppose.
No worries.
Anyhow, in the meantime, just to save time, I would like to thank Leonidas for letting us participate in this project. And as a side joke, I should say that the reason for which we met and we met each other is the reason for which we are here today, because we met each other in robotics and an educational robotics contest. As participant, Leonidas and his team, I was the organizer. So this brought us close enough, and we saw that we have some common things that connect us. Anyhow, I would like to thank him for giving us the opportunity to participate in a project like this. To be honest, I think that our use case is a side project, the side effect of the RC Hub idea. I represent the team I represent is called Talos, which stands for Thinker, Advance, Learn, Observe, and Search. So all of this makes the name Talos, which was an ancient creature in the mythology. Anyhow, Talos team consists of a lot of people in specializations. We are teachers, informatics scientists, engineers, and Talos is okay. Yes. I think this is Leo's presentation.
Yeah, I'm trying to bring it.
So you use the MS Teams to upload something to SharePoint, something like that, right?
Yeah.
Okay. It makes sense. No worries, sorry. Take your time.
Really fine.
Yeah, I'm gonna cut a long story short, because if I start speaking,
Try to post that. Which one?
So at the moment, write down the acronym Talos, which was an ancient creature, right?
yeah, exactly, in the mythology, it was an ancient robot.
An ancient robot.
Yeah.
Yeah.
I think this is it. It's in PDF format because it's easier for you to read.
Perhaps the people here were.
Is it here?
Is it?
Yes.
This is it. I think this is one, yes.
Okay.
Okay, this is the PDF.
Let me tell you that one of the cities where the University of Thessaly is located is Volos, which was an ancient place, a famous ancient place. Perhaps you have heard of the story of Argo and the
Argonauts.
Argonauts.
Anyway,
For the gold, how was that?
we have to go back.
Iasonas. Have you
Jason.
heard the story, Jason?
Okay.
Use the boat. No, it's good for them to know because perhaps
Yes,
some of
they
them
have-
will come to our university as visitors.
Let's hope we will host you
Yes,
someday in the future.
At least
Anyway,
for the purpose of the workshop.
the team I represent is called Talos. It is all about some after-school activities for children. We offer workshops for children regarding computational thinking, educational robotics, coding, and stuff like this. I think I don't need it because I have the mouse here. It is a project that has been running since 2016. And why all this matters, I just want to put you in the big picture of what we do. We run STEM activities. And one of the things that we have done in the past with children aged between 14 and 16 years old, we built a seismograph out of Lego EV3 pieces. And this gave us the opportunity to measure earthquakes. So we have created a small earthquake station about measuring earthquakes in the university. And this has all been designed and implemented and monitored by children with our support, of course. So this means that we have done something similar like what we're going to do in this project in the past. You can find some information on our page here. It's all Greek to you because we haven't yet translated in English, but that's another story. Leo used the phrase "make sense" before. He didn't know that I have named our use case like this. Make sense means that we want to engage children and their teachers in the process of making sense of what the air around us is consists of. In other terms, is it safe for people living in our city to live there? How polluted is the air? How clean is the air? So the current case study is about creating, in a few words, creating a network of sensors that will be installed in some schools. Children and their teachers will be engaged in the process of building these stations and learning how to work with them and how to monitor data and how to process data and how to share data, because this is the point of SC Hub anyhow. So we're talking about formal and non-formal learning activities that will be based on the creation of such systems for environmental monitoring. So the keywords for us, because we have a big interest in the project in terms of educational and learning design, but of course for the SC Hub idea, the point is that we are going to contribute data that will be shared with the community. The keywords for us is about citizen science, how we can involve, engage citizens in creating and disseminating and sharing data. So for us, it is also interesting, the term of digital citizenship. We are going to talk about the ethics of collecting and sharing data as well. And of course, what we're interested in is gamifying the process of learning about sciences and about terms and processes that seem difficult for children and for people that don't have any idea of how technologies work and how we can monitor and measure environmental data. So the relevance of our use case with the big idea of the SC Hub is that how do we fit in this project? That's the main question. I just talked to you about this before. We are going to engage children and teachers in the whole process of gathering data. Children, of course, are not aware of a lot of things about environment and technical stuff. This is what we are here for. We are going to organize some workshops for them as well for their teachers. We're going to use Raspberry Pis and Arduino based systems in order to create small stations that will gather data regarding the air quality. And just to tell you that Volos, our city where the university is based, is a city that suffers from heavy air pollution. So this concerns everyone in the city. It has been a problem in the last 10 years that has concerned every people living in the city. So I think that the interest for the stakeholders will be that they will get to know about the real situation in their city through the use of low cost. So this way, learning how to build such stations, learning how to code in order for the stations to work. We hope that we will make people become more interested in the project and in the citizen science model, which means that all the citizens can contribute to the bigger idea regarding our city in terms of air quality, of course. So the SC Hub platform will work for us as a digital place where we can share our information. So this will give us the opportunity to share our concerns and the conclusions to which children and teachers will arrive through the use of such systems. You see that the whole citizen science model is about engaging citizens in gathering or even producing data and sharing with the community and the scientists. Because one of the biggest problems that we have in Volos, for example, is the lack of monitoring systems. It might sound funny, but the whole city doesn't know where the air pollution comes from. We can imagine that this could be based on maybe the ignorance or maybe some deeper thoughts that all can come to. The suggested educational methodology, because this is of main concern for us, is the design thinking process, the problem-solving processes, and the project-based learning. All this will fit together in the process of creating small environmental monitoring stations. And this is something that has happened in the past in the smaller scale project in Italy, in the Reggio Emilia community, where the schools are very active in projects like this. But of course, we're talking about smaller ages and younger children. In our case, we're going to engage all levels of education of schools, beginning from kindergarten to secondary education students, pupils. Of course, this means that not all the ages will be engaged at the same level of difficulty in the project. So we will have a different approach for every age. So the aim, as I said before, is to develop a network consisting of sensors that will gather and monitor air pollution and environment, at least in our city, in Volos. This will be this network of sensors that will be distributed in a lot of places within the city will communicate with a centrally controlled monitoring system that will be installed in the university. And this will be a more expensive one, as you can see in the first bullet point. The target is for us to build let's say the central system. We expect it to cost something less than 200 euros in order for it to be as accurate as possible. And all the other stations that will be installed in schools will be the digital twins of the central system. We will try to replicate the sensors of the more accurate system in a way that will be understandable by children. But in order to validate the data that children will gather, we will have to validate them through the comparison with the actual data that the central system will gather. So one of the side effects is that data will be accessible through the use of the SC Hub, of course, that all this data will not be wasted, will be gathered in the hub, in the SC Hub, and will be open and accessible to almost every people in the city. So this means that we will not provide useless information and data about what all the people. Yes, because you know that the problem mainly today is that we produce a lot of data that doesn't mean anything to anybody.
Exactly.
Something like a proof of concept for what we are going to do is a project that we have been running since 2018 and 19. It's something similar. You can see some photographs of pilot testing of then built system. We participate since then in the Climate Detective Challenge of the ESA, the European Space Association, which is a very interesting action taking place until today. So we have some experience in working with kids on similar projects, but the innovative thing about our participation here is that the data that will be produced will end up in a centrally monitored and controlled hub like the SC Hub, and this will make the data visible to anybody. But we are mainly interested in, of course, I forgot to mention that my specialization is about learning design. I'm an associate lecturer in the university, and I teach future teachers about how to deploy innovative technologies in educational design. I should have mentioned it before. I'm not an informatics guy. At least I don't have the technical experience that all of you guys have here. So we're mainly interested in seeing how this experiment will translate in better educational design, how we can deploy all these modern tools the best way possible. And of course, we expect the SC Hub to help us disseminate this data. And of course, we hope that our data will be as valuable as possible for the hub as well. I hope I didn't make you want to go to sleep because, as I said before, we are a side project and we are a use case that tries to experiment in both worlds, either the one that has to do with technology and the other with educational design. Our experience is a mixed thing. I hope that we can contribute to the project from our side. Thank you for your attention. If you have any questions, as I said before, the last thing is that this network, the aim is to build a low budget network, even if prices have skyrocketed in the recent months, because you expected to buy a Raspberry Pi in the past for 45-50 euros. Now it costs something like 80 euros. But anyhow, we intend to build small, low-cost stations for some schools in the city, and this way distribute the responsibility of gathering data from different places the best way possible and in the most understandable way by younger people, and make them engage them in the social process.
Okay.
Thank you.
Thanks very much, Spiros. May I have
Yes.
the mouse?
There you go.
Thank you.
So both.
Going to see we have something in the chat box. Showing what's the message or and feel free to send your questions to the chat box. And yeah, thank you so much, Jean, for your nice message. And that's to you, Leonidas and Spiros. Jean is from the School of Business. She is a faculty member in the school. Thanks very much, Jean, from your side. And do we have any question for Spiros?
I hope it was clear that we are trying to achieve in two different objectives by the engagement of Talos. First, to show how independent teams of end users can submit different types of information to the hub. And again, you engage students from the early ages to be transformed to digital citizens and develop their ideas that make them feel, make them understand, making smart city useful for their activities, to bring them closer to what the city does, to what the smart city does. So this is a two-dimensional effort that we're trying to do together. And of course, open up new ideas and new questions.
In fact, it's something like preparing new citizens either as users of the hub or as contributors. And let's not forget that we're talking about the future colleagues. They're going to make use of such platforms or even create new ones. So we're not talking about something that is it's of low interest. So as Leonidas said, it's a dual objective.
If anybody has a question, can I ask something?
Yeah.
Absolutely.
Thank you very much.
It's a workshop.
Yeah, thank you very much for the work, the very interesting presentation and sharing all the information regarding the project. So I was just wondering, there are also different online platforms for engaging with citizens and getting their feedback, probably for different services. So is your project also going to integrate that kind of data, or is it just the sensors that you try to get data for different purposes?
Thank you. This is a good question. Actually, what we tried to show in the first presentation, and of course, Yannis can also contribute to this question. This SC Hub can enable any kind of platform to collect or transmit information via the SC Hub. For the purposes of this project, we will not make any other integrations to show what really goes on. We will do some testing with a smart city platform. The usual one, it's from InVipo, located in the city of Trikala. We will also use information from different resources that I explained to you before, Internet of Things and use cases, and show what is going on via a prototype. So we will just develop something to show what is really going on, but we will not do any integration.
Right.
The hub will enable integration. Sorry.
I just wanted to add to that one. Exactly as Leonidas said, we focus mostly on the, if you like, the primary or the raw information produced by the smart city. If you think of smart city as an organism or as something dynamic, it produces a lot of information, which is accessible to us through the sensors. So the sensors could be water meter sensors, parking space sensors, power meter sensors, traffic light sensors, any type of sensors that they are already now deployed in the major cities of the Western world, but it's very hard to have a unified approach to that. It's very fragmented and it's very vendor specific. So that would be the main purpose of the hub. On a second or a third level, that could be used in other platforms, as you described. For example, it could be used for citizens to provide direct information, for example, of their air quality. Like in the Volos example, we don't know where the pollution comes from. But if we can imagine having a central portal that would connect all the information available in the city of water pollution, it could be from the projects of Talos, from private companies, from other pilots that are running in the city in a unified way, then someone could use this information to create their own platform using the data that hub provides. And on that platform, they could engage the citizens and say, what is your private opinion? According to the data, it shows that here it should be very polluted. What do you think? Is it or is it not? So that's one potential use case of an added value service on top of the data that we collect. So we don't want to create a universal thing that does everything. That's not possible. We focus only on the raw information that is very fragmented now and not standardized, to make it more unified and more standardized to allow the faster development of added value services, which is one of what you described.
No, thank you very
So,
much. Yeah.
For instance, if you want to know what kind of educational information exists in the city, you can go to the hub and see what types of resources exist there, like the GitHub, perhaps you want to have access to available under development applications. I hope we answered your question.
As Giannis said,
Thank you.
this is all fragmented and it's difficult for people to find the information they need when they need it. And what it was when Leonidas suggested that we participated in this project, from our side, we had in mind the educational added value, of course. But what was the most interesting idea to my ears is that it translates the data that is wasted. It gathers and translates the data that would otherwise be wasted in a unified virtual place where it is visible by anyone. So, for example, in the case of Volos, because it is the city that I live in, it's a very serious problem. Everyone, at least the authorities, pretend that they don't know where the pollution comes from. So the power will be in the hands of citizens. Let's say, if I install the station in my house, that would be nothing. But if we gather data from different spots in the city, and we have a platform that can gather all this, then the data can be translated by virtually anyone that will have access to this data. So this means that we can also create new, visions of the data, and we can translate it not the way that we like, but the way it should be in a more objective way. And the problem is that many of the citizens, the people that live in Volos, for example, don't have the faintest idea of what the level of pollution is. So if we create an index of the levels of pollution, easy to be understood by even illiterate people, that would make a difference, of course.
Yeah.
I think so, at least. And as I said before, our stations, in our use case, will not be the most technologically perfect ones, of course. Giannis knows better than me that in order to create an accurate sensor, you need to spend a lot of money. But of course, it's better than nothing. And for us, the added value is the educational value for the educational community, of course.
Of course, this is perhaps, Spiros, a good idea to investigate if other educational repositories exist in the area and try to see if information can also be broadcasted.
I told you before that there is already an earthquakes measuring
Exactly.
network. Yanis knows the main person behind this system. It's Grigoris, of course, you know, Milopoulos. It gathers information from all around Greece, but on the other hand, this network is an independent one. I think that we would prefer to have all this data gathered at the same place. It could make sense if you combined information, for example, earthquakes and environmental pollution. I don't think that we could combine and, you know, gather conclusions from this combination of data. But of course, in other fields, maybe, for example, the pollution mainly depends on temperature values and humidity values. If we brought all this data together, we could have a clearer idea what is happening.
Let's see. Let's see.
Thank you very much.
That's all.
Unfortunately, I need to drop from the call right now. So great
Yes.
meeting you all. Hopefully next time it will be in person.
Yeah, nice to meet you, Yanis.
Have a nice rest of the day.
Thank you
and
so
looking
much.
forward to- Have a nice day. Bye-bye.
Thank you,
Bye.
Yanis.
Thank you, bye.
See you, Yanis.
And we are going to say goodbye to other online participants, and Sana and Gultekin, if you would like to join us, I'm going to send you the link for the Teams. Otherwise, the online part of this workshop is going to be finished, and thank you so much to join us and have a nice day and also weekend. Thank you so much. Bye.